With that, my name's Yong. I'm a product manager in the Cloud Spanner team, and I have several other speakers with me. Neera Mittal is our senior software engineering manager. She's one of the people who work the magic behind what Spanner can do. I also have Markus, our chief technologist and IT lead for cloud online banking from Deutsche Bank. And of course, we have the illustrious Adrian, founder and principal analyst from IT Market Strategy. You may have known him from another very popular place that knows a lot about IT industry. Now, real quick, this is our agenda. I'm not going through the bullets. Everybody can read here, but I do want to set the stage on how we're going to go through this by stating why we're here today. This architecture diagram, or this high-level architecture diagram, has Spanner in the middle, but this is very common for almost any database application out there, where you have your key OLTP application, your transactional application, that's your most important piece, talking to your database. It goes to a back-end processing engine of some sort, it goes to storage and gets data back for you. And you probably have a bunch of other workloads that could be analytical, reports, ETL, pushing data out for compliance reasons and whatnot. You probably also want to feed data to your wonderful AI models so they actually have useful data and sensible, relevant data as you train these models up so they can give you great answers. So this is the stage that we're looking at. Most of you who are here are probably quite familiar with this layout. You may have some variations, but we're going to get started with looking at how this works. And Markus is going to come up here and describe how Deutsche Bank has actually taken this and modernized their environment and what they look forward to coming from Databoost in the future. Markus?
Thank you, Joey. So first of all, let us get started in looking into what we are doing in the German banking industry and how we're present there, right? So Deutsche is present with two distinct brands in the German market. So we're having Postbank first, which is serving the, we call it daily banking activities, right? So you're classical, you're making a transaction. You're going to an ATM, or you're doing basic investment functionalities like buying a stock, selling a stock. On the other hand, we have Deutsche Bank, which is focusing more on the advisory part, complex financial products to serve you with. Together, they're present in over 1,000 branches within Germany. What is, compared to the size of our country, a lot. So, but let's dive into the technical history of those two brands, right? And join me in 2020. We sat down and looked into the IT environment setup of both brands. And they were completely separated. They had separated environment, no synergies. I think a classical setup for many large corporations. And if I say environments, I mean data centers. So both operated their own data centers. What is normally happening in such a situation for large corporations? Those corporations go there and think, okay, which is the better system? Which one do I want to migrate onto? And then you go on a journey. You focus on your migration to get rid of one and focus on the second. Probably after 2, maybe 3 years, you will finish your journey. You've done your migration. What's next? Oh, you focused on migration. Let's start with the tech refresh, right? So back in 2020, we had been in the luxury situation of kickstarting our Google journey together, the partnership. And what we said is, let's do this properly. Let's build up a third platform from scratch, cloud native, where we'll put our customer data on and that we will serve our customers from. We called that the customer interaction platform. And the fact that I'm here today shows that it has worked out. And today we're serving Postbank customers from a completely cloud native platform, leveraging over 50 Google Cloud native services. This is where we are today. As you can see there, there's a roadmap what we're following on. But let's first of all, let's dive a little bit into online banking as a product itself. So I said customer interaction platform. Platform because it's the single point of contact for the digital channels. Either if you're coming from a mobile application of us, if you're coming from a third party that is aggregating your account statements, or classically going to our web page. All of those are being served over that one platform. Important to say, that platform is not limited, for example, to our retail customers. It serves all kinds of customers. The small retail customer, our private accounts, but also corporate accounts. now I mentioned we have migrated Postbank. Let's get a little bit into numbers, right? And over those Postbank customers, more than 5 million have activated online banking. They're representing today more than 16 million transactions a day. And something I'm personally really proud about is, if we're looking at on-premise system, regulated industries, we have a lot of applications who are running quarterly release cycles. We have brought that down to a bi-weekly, aligned to our sprint cycles, release cycle. And as part of the migration, you can imagine we had some more releases going on. So already we're above 300 releases on that platform. And that is, for the teams, for us, that's an important number. Now, let's dive a little bit into the requirements such a platform has. And if you're looking at this, the first thing that comes to your mind as a customer is your financial overview, right? What are you using for your bank? What is the most important topic for you? Do I have money on my account? How much do I have? Has the rent gone out? Stuff like that. If you think about what it comes from a requirement perspective, you're talking about availability. You're talking about right, accurate data that you expect from a bank. This is key. On another example, in Europe we have something called instant payment. That means we have milliseconds. If you do a transaction, that it needs to arrive at the other bank, get deposited there, and get deducted from your account. We're talking milliseconds. What is the first reaction you do after such a transaction? For example, you paid for your car. You go to your financial overview and you want to see that those money left your bank account, right? Looking at this, we call that a critical workload in our bank. And for this, we paired up with Spanner. Now, let's look a little bit into the requirements towards Spanner and the great team behind what they did. I'm not going through all of them, no worries. Let me focus on two that are the most important for us. Let's talk about the availability I just mentioned. We're operating Spanner in a multi-region setup, and that gives us 5 nines of availability. If you're into availability discussion, you understand what it means to have that baseline of availability guaranteed by Google. That's a key feature for us to serve our customers to meet their expectations. On the second hand, I mentioned performance, right? And I mentioned those 16 million transactions. What I did not mention is that some of those customers are handing in 300,000 transactions in one go. Just imagine one customer having 300,000 transactions processed, and in the same point in time, you want to pay your car that you just bought. Would you be willing to wait until that transaction comes up? You're probably standing in front of the dealer like, I made that payment. It better comes up. So this is what we're using Spanner for, and I'm actually quite happy with the performance, everything we saw, especially with the great team behind Spanner and the product management from Google and all the colleagues we're working on the ground with from Google. Something I do like to talk about is constant enhancements. As a bank, we're coming from a legacy. And probably all of you are aware of that product where you had version 6 and the project to upgrade was delayed and then you couldn't and you stick to that version. Or there was no major version coming and then you're in the situation of being incompliant. So we are really keen to work with products where we see the owners of those products are actually pushing forward and bringing enhancement and development in. One topic I would like to talk now about is scaling, exactly to say auto-scaling. So I mentioned that we migrated Postbank onto our new platform. This was actually the biggest banking migration ever done in Europe in history. So we're talking numbers. And we're talking requirements where we actually shut down the bank. So for customers, during that, we call it cut-over weekend, they couldn't reach the bank. They couldn't transfer money, they couldn't get access to their bank statement, and they couldn't come into a branch and make something. Because we literally migrated everything. From finance over the CRM, we migrated everything. And when you think about that fact, you want to have that as short as possible for your customers, right? So what comes to your mind first is, let's scale our infrastructure, right? How can we increase the processing time? And I remember that moment when we did the analysis and looked what it mean. So there were databases where we thought, okay, we need to double them. That's something we've seen in our on-premises state as well, doubling infrastructure. We looked at some of those databases and we talked 13 times the scale we needed for a short period of time. Now there's only a limited amount of manual scaling you want to do. And then we reached out to Google and said, hey, how do we do this? And Google actually came back to us and said, oh, one engineer did something. It's on GitHub. It's open source. Let's look into that jointly. And one of our really passionate lead engineers took that baby, I would say, to him and run a POC together with Google. And we do call this production ready. If something can go to production, if we tested it thoroughly and know that it's suitable of running our production load. As part of this production ready state, there were enhancements made, and there was that point when he came back to me and said, Markus, can I roll it out to production? And I was like, are you comfortable with it? And he said, I'm comfortable with it. Google is, let's do it. Actually, there will be a blog post about this published by Google and Deutsche pretty soon, because we really believe in this to be an important partnership piece. And we're proud of it to show it, and we gave it back to the open source community. So you can run on the same auto-scaling that we do run with our whole environments, dev, UAT, and production. So key point for us and showing the partnership that Google is interested in. Now, let me quickly touch base back on the points I gave to you from a roadmap perspective. Because obviously building up a platform means owning it and developing it further, right? And you've seen that we're with Postbank Live. Now we're looking at our second stage, Deutsche Bank. You can imagine those customers, wealth management customers, having 14 different accounts, different currencies. They're demanding, right? So we want to do this right, and this is the journey we're on because we believe in the platform. Something we talked a lot on this conference is AI, right? What is the baseline for AI? It's data. Now, having all of that customer data online related on a data platform is key for us and enabling us for new products, new features. Every new feature development that we do is done on that new platform, fully cloud featured by Google. Obviously, something I'm personally looking forward to is talking about other legacy systems in the bank, but this is the journey you embark onto, and we're here after 3.5 years. Now, let us look at one situation. We're here for data boost, right? So you understand that information production is very interesting. It's the transaction data of the people they're doing. In combination with something really important for us, the fraud data behind it. Because if you want to make a transaction in online banking, you need to have a second factor approval to let that transaction go through, right? I have both that data in my production environment on Google Cloud. Now, I would like to use that, right? What we classically did is we copy over that data at night when not that much traffic is on to a data warehouse, and then days or even weeks later you analyze it, right? This is where we want to move away from. And for that case, we're highly interested in using our production data to analyze it on the go and to perform decisions for fraud detection on that. But without going further into that data boost topic, I would actually hand it over to the right person to do that. Joey, back to you for the explanation of data boost.
Thanks, Markus. So going back to the slide that we started with, so this is the context. Whether you follow the journey that Deutsche Bank and Markus-led team did, where they modernized by merging systems from on-prem and moving them onto the cloud, or you already have it sitting in the cloud, the same scenario exists. You have your most critical, latency-sensitive transactional systems. And then you have all of these other really interesting things. And again, I kind of joke a little bit about the AI part, but the reality is your AI models aren't terribly useful if they're not trained with relevant data. And those of you who actually have deployed ML models in production today, give me a show of hands that you actually have a regularly scheduled retraining of those models. How many of you do not? Okay, a couple of honest people here. Very good. So what happens when you need to run these kinds of workloads, and what happens when you need to run analytics? What happens when some, I don't know, colleague attended a conference, let's call it some other tech conference, and they learn how to write SQL, and they learn how to write a join, and they have access to 2 tables that are about 1 trillion rows each, and they decide, I'm going to run that in my production system because I want to get smarter decisions. Anybody experience that in your production environment? Only a handful? Y'all are lucky. So I used to live the DBA life, and I gave that up because I didn't like my pager going off at 3 in the morning anymore. Of course, now we're all in DevOps, so my pager goes back on again 3 o'clock in the morning. We looked at that hard in Google, and we decided that, you know what, traditional approaches help, but they don't really solve the problems. You can move data using ETL to a separate system, but eventually your ETL becomes another heavy load against your system. You can also create replicas, but that has additional costs. And guess what? Replicas require data movement, and you pay a cost. You can have resource governors, but these things also have limitations there. You have to make a decision when an expensive query or a high priority query comes in. Which query that is lower priority will you kick out of the system? Which one will you terminate? Those are non-trivial decisions because kicking a database query out doesn't mean that you can run it back in the next second. It may actually take you hours of work to get it back to where it was. So we figured that's probably not a very good approach. And that's where Data Boost comes in, where if you notice the colors of the arrows have changed, your transactional workloads continue to run against your original provision spanner instance. That just works. Nothing changes. But just by doing 2 things, you grant an IAM permission, that's on the security control side, and you add 1 configuration parameter to your connection string or to your connection object. Literally, just these 2 things. 1 security setting and 1 optional parameter you add to your connection string. Spanner will know that these queries that have these 2 criteria met will be automatically rerouted to completely isolated compute resources. As you can see in the diagram, they're completely separate. The compute resources are isolated, and these are managed by Google. You don't have to worry about provisioning, sizing, and whatsoever. They're always hot. They are always sitting there waiting for queries. This is not scaling up or down. This is always sitting there waiting for queries to come through. As soon as they come in, there's no latency. We service that query immediately. We go into Colossus storage. And this is another advantage of Spanner. Because our compute and storage is disaggregated, this is our architecture from day one. We are able to look into the actual physical blocks on disk. There are the exact same blocks as your original Spanner instance. There's no replicas here. You don't pay for copies of storage. There's no latency involved in terms of, oh, let me go create a block of this so I can read off that. All of this stuff hits you live, no query latency. We process that, get the data back that we need, do a quick check with the Spanner, your provision Spanner instance to make sure nothing in memory needs to be carried over, and we send it back to the client. So that way, you can literally go run that big join with these 2 trillion row tables, and nobody on the Spanner side would even blink. And this is really, really hard to do if you don't have the same architecture and the same technology underlying Spanner that we have today in Google. And I should say this, and I know this is an engineering crowd, but one thing is important here. This is also a pay for the actual query consumption in terms of compute resources. So this is not something where you over-provision and you sit there, it's 80% idle, and you get really busy 20% of the time. So I know engineers here are thinking, what do I care about pay for consumption? It's budget, somebody else manages that. But hey, imagine, right, if you save a lot of money for the company, maybe it goes back into your bonus, or at least the party fund. Now, we talked about quite a few of the benefits here. I'm not going to go through each of these in detail. They should be quite obvious. But one thing I do want to call out, the last point here, it does reduce data sprawl because you need to make fewer copies of your data. Direct federated queries against your production instance becomes feasible, becomes very practical. Your pager doesn't go off at 3 o'clock in the morning anymore just because somebody got off of a conference party and decided to start running queries against a production instance. That never happens to any of you, I'm sure, but that's happened to me in a previous life. Literally, people get out of a conference after the party and decided that, yeah, I only have 4 drinks, at least that I remember. Let me go see what's going on in our financial systems. One of the things that's really cool about this is we tested this. We went through it in queries and figured that, oh, let's go try that really expensive queries that our friendly analysts run. On the left side here, you will see that this is the actual query run on a production instance of Spanner, and you see the CPU spike, and it stays up there for quite a while. Those with really good vision, you'll notice that some of the spikes actually stay up there. This is CPU running up there for over several minutes. On the right side, the only thing we did, grant permissions, enable that connection string parameter, and you don't see the CPU jump anymore. No code change, no schema change. It just works. And of course, because we are running on completely separate compute, we are also able to make more aggressive decisions about parallelization, about how we want to execute and optimize the query. We don't have to worry about impacting other workloads. So this is another advantage. This is a very modest 8x performance gain. We've seen as much as 100x perf gains. Of course, sometimes we see as little as no gains, 0 literally. So it really depends on your workload and the kind of queries that you're running. No amount of hardware will solve really, really bad queries. We'll make it better, but we can't really solve bad queries. This is just an example of some of the workloads that are supported. On the bottom right corner, you see we already have a bunch of ISVs supporting it today, even though we literally just announced the product. They were so excited, they decided, you know what, we're going to get this working even before UGA. Now, all this talk is easy. I only have slides. So my colleague, Neera, is going to come up here and show you live demo of how this actually works. So this is live, so everybody, just send good thoughts to her and make sure the demo gods are working in her favor. So, Neera?
Thank you. Thank you, Joe. This is super exciting. Hi, everybody. I am Neera, and I have the awesome job of presenting the power of Data Boost to you all. So let's get started. So in this ever-evolving digital world, gaming is an important experience in which gamers are spread throughout the world, yet connected. An integral part of this experience is the game tech that fosters innovation and transformation by enabling low latency experiences for gamers irrespective of their location, irrespective of where they are connected from. So in this demonstration, I'll be using an online multiplayer gaming scenario in which the gamers are going to exchange merchandise, they're going to acquire items, they're going to loot items during a session, they're going to use virtual currency to buy items. The gamers are super excited, getting ready for their next battle, acquiring the next weapon. They're looking forward to acquiring the next avatar, customizing its appearance. So we can see that this requires low latency experiences with transactional consistency at horizontal scale. So this is where we use Cloud Spanner as a backend, as the operational database. Now, while all this is happening, we have the gaming analysts who want to analyze this data. They want to slice and dice the transactions. They want to see what's happening, what merchandise is being exchanged in these weekend-long gaming marathons. So the way this has been done typically in the past is either by over-provisioning the operational database to avoid impacting the real-time transactional workload, or maybe by creating copies of data in replicas, read-only replicas, or maybe by moving the data out from the operational database to analytical warehouse, thereby creating staleness in the pipeline. And this is where steps in Data Boost. As my colleague Joe explained, Data Boost harnesses the power of Cloud Spanner's disaggregated compute and storage architecture to enable large-scale analytics on operational data with isolation. No impact to your transactional workloads. So with that, let's get started. Let's switch to the demo. And while we start, against all sane advice, I am feeling a little bit courageous and I'll try to do a live demo. So let me kick off this query and I'll explain what it does as we go through the flow. So we can see that this is a game Data Boost enabled query. This is on a Data Boost enabled connection. I'll walk through the flow as we go through it. So this is my Cloud Spanner backend database instance, Unicorn game instance, on which I have a demo game database. I will walk through the schema of the database. This is a typical online gaming setup where we have the players who are participating in the online gaming sessions. The player acquires item, loot merchandise, we maintain their ledger, we maintain the trade orders. So now with this, let me try to analyze this data as an analyst through BigQuery. So to analyze this data from BigQuery, I'll create federated query connections from BigQuery to my Cloud Spanner backend instance. This is the first connection. data boost disabled connection. As we can see in this, use data boost is set to false, use parallelism is set to true to harness the power of batch queries, and this is on the same unicorn game instance and demo game database that we just saw. Now I'll create another connection which is exactly similar. This is again an external query connection. This is a data boost enabled connection. We can see that the use data boost is set to true in this one, and use parallelism is also set to true to harness the power of batch queries. Again, it's on the same unicorn game instance and demo game database. So now with this, let me try to run some analytical queries and see the results basically. So this is a query as an analyst I'm running, where I am trying to analyze the players who run high value transactions, get some statistics on their list price, the number of transactions they took to achieve that. So we can see that I ran this query at around 2:45 p.m. It ran roughly for a period of around 11 minutes and ended at 2:56 p.m. So now let's look at the demo game database instance CPU load at that point, and we can see that the CPU spiked to roughly around 40%. Now imagine a scenario where you have millions of gamers spread throughout the world doing these transactions in real time. You have hundreds of analysts analyzing this data and the kind of load that's going to put on the operational database. So now let's try this query through a data boost enabled connection. So this is the query that I just ran at the beginning of the demonstration. This is the data boost enabled query, and voila, we have the results here already. This was a 10-minute query on a data boost disabled connection, and out here we can see it's the same query that ran at 3:55 p.m. for a period of roughly around 1 minute. And if I go to the same CPU spike there and trying to see if there's any CPU impact, there's nothing we can see at around that point of time. So there's no impact on the operational database as I ran this query, thereby proving the power of isolation of data boost. And another important thing to note here is this query ran in 1 minute, whereas the data boost disabled query ran in 11 minutes. So this query got a perf gain of 10x by moving to data boost. Now I'll try to play the role of an analyst who wants to do slightly more complex analysis. So for that, I'll move on to my Jupyter notebooks. I want to do a cohort analysis now. So as we all know, when we want to do slightly more complex analysis, doing that in declarative SQL is a little bit painstaking. So I will move on to imperative Python in my Jupyter notebook. And by moving to Python also comes the power of using analytical frameworks. We can use Spark. So for this demo, I have used Spark. As we can see, I have loaded the Spark connector to my backend database here. And this is the same unicorn game instance database, the same demo game, and the enable data boost is set to true. I'm also going to use analytical frameworks like PySpark and Pandas to demonstrate the power of ease of using them in this demo. So for that, I have some utility functions, and we can see that basically for cohort analysis utility functions, I have used PySpark. I have also used Pandas for this analysis. So moving further, I load my data, and this is a large-scale analytical query that I run. Basically, we can see that this query ran at around 12:06 p.m. today. It ran roughly for around 8 minutes. It scanned 4 billion records. Moving on to my metrics explorer, again on the same demo game database instance. And when we can see that when this large query ran, the load on my operational instance was only 0.6%. Thereby proving the power of data boost. Basically, you can make large-scale analytical queries and it will not impact your transactional workloads. And these are the results of my cohort analysis. For this cohort analysis, I divided the players into a group of 3 cohorts and measured their retention along the weeks as the gaming session progressed. So for the first week, we see 53% of the players remained in the second week, 9% in the basically week after that, and 9% further down, 9% in the last week, and then we have the retention of players across the other 2 weeks. So in a nutshell, we can see with this demo that using Data Boost, you get true isolation for your transactional workloads. You get the benefit of performance depending upon your query shapes, and how easy and simple it is to use Data Boost. You can use it from BigQuery, you can use it from analytical frameworks like Spark, you can use it from data processing applications like Dataflow, you can use it from client applications, and it will give the ability to run large-scale ad hoc analysis with true isolation. So thank you all. With this, I'll hand over to Merv, who's going to talk to us about what Data Boost means for next generation data management.
Thank you. Am I on? Yeah, okay. So, can I have the slides? All right. So some of you have the luxury of being able to go to whoever writes the checks for the hardware and software you use and show them a demo like that and have them understand of it. Most of us don't. And so they bring in people like me, industry analysts, who say, well, what does all this mean to you? That's my theme here. It's the bigger picture. How does this stuff fit in? We're talking about the next generation of data management. Preparation meets opportunity and transforms how you do what you do, what it costs you to get it done, what kind of results you have. So consider the basics. You know, Joe laid this out very nicely. It would be nice to have unlimited data scale. Very few of us can assert that we have that. But, you know, the way that management sees this is, I'm in the cloud, right? Isn't that why I went there? I've got unlimited data scale. Yeah. Of course, costs may be unlimited too, and they're less eager to hear that story. So to the point of, should I make multiple replicas of this in order to get the performance I want? Yeah, that sounds great until you have to write the check. Similarly, I have unlimited compute scale, don't I? Up in the cloud? Yes. But do I have access to it? And even if I have it, is the storage of this system prepared to handle multiple different high-level compute loads being thrown at it at the same time? That's what we call workload management. Most systems do not do this gracefully today. So, if we turn people loose and only drive our plans on the basis of what we think we need and the assumption that we can do anything we want in the cloud, we're going to have a rather large curve of costs, but we're also going to have to deal with security issues, and we're going to have a great deal of semantic confusion because different people looking at the same data may think it means entirely different things. So we need to be able to manage this in a uniform, governed way. In order to move to a world that's as happy as the one you just saw, we need to handle a number of things. And all of these things need to be handled in the context of today's environments, which have, you can think of it as a ceiling. We can push this so far, right? So whatever we deploy needs to be intelligent. It needs to know how to use the available resources. It needs to be observability enabled, so that if I can put in something that manages the operation of this system and doesn't require me to wake Joe up at 3 in the morning by ringing his pager, I have to have observability on this system. This system has to be self-reporting, and it has to send those reports to something that can do something about what it's learning. That's governance. The system has to be governed, and it doesn't just mean I know lineage. It doesn't just mean I know the users and what they're allowed to do. It means the operation of the system itself needs to be governed. I have a ceiling. If I've got 40% of my CPU being utilized and you need to pay for your car, as Markus described, you don't want to wait while those other jobs run. And so I'd like to have that unlimited scale. I want that scale to be there when I need it, and I don't want to have to stop to make it available or page Joe to make it available for me, right? I want that to be autonomous. I want the system to take what it needs to meet my requirements when the system needs them. And I need all of this to be integrated. I don't want this to happen in 4 different consoles. I don't want multiple players who have to set this up. I'd like to set 2 parameters and just have it run the way you saw earlier. In fact, you know, in a perfect world, I'd like not to have to set those parameters. Oh, let the system do it. But I know you're getting to that. And finally, what I want is for that operating system then to be optimized for me. Not just in terms of its performance, but also in terms of how I pay for it, when I pay for it, even whether I pay for it. I don't want to pay for what I'm not using. And that's what over-provisioning is all about, right? So I like to say to people, if necessity is the mother of invention, choices are its children. When I build systems out of necessity, I have to make a lot of choices, and some of them are very uncomfortable. And until now, the choice of can I scale the way we're talking about was a simple one. Let's spend a whole bunch of money and buy a lot of capacity that most of the time is going to go unused. That's not an acceptable answer. That's not the choice we want to make. We've got a ceiling. We don't want to have to figure out how to live within it. So today, at the end of, let's call it the first era of cloud data management, as we move into the next, we have a lot of those choices to make. How many of you guys thought when we moved to the cloud, everything would be simple in terms of configuration and, yeah, thank you, Markus. You know better. Ever see how many instance types there are? I don't consider that particularly simple. It gives us choices, though, and those choices are important. When I need a certain thing, I want an instance that'll do it for me. Ideally, though, if I have the autonomy I'm talking about, the system will do that for me. In fact, it'll, because it's observability enabled, look at the workload, and it'll say, well, what this thing needs is some TPUs. I'm running a model. Let's give it the right kind of processor to run that model on. What other kinds of choices? Well, what format do I want the data to be in? Do I accept the one it's already in? Can I operate against that format, or do I need to make another copy of it somewhere else in a more optimized form to run it that way? I have a very simple rule for copies of data. You should have as many copies of the data as you need, and not one more. So the system will tell you how many copies you need if it can handle it in the format it's already in. But you may have other reasons that drive that choice. It might be the language you're using, the fact that it's a legacy system that can't easily be changed. Well, there's more choices here, but I don't know how much time we have left, Joe. I'm going to try to, oh, I got 6 minutes. I didn't see I had a clock there. Thank you. All right, so let's talk about 1 or 2 more of them, because they're important. What about the cost of moving data around the system? Import, export, okay? Duplication, refresh. In a system that has massive amounts of data, like a gaming system, how much do I care about the behavior of the users 6 months ago? Or the behavior of the users 3 months ago? Or the behavior of the users yesterday? In the scenario that you saw demonstrated, what I really want to know is what users are doing right now. And maybe what they've been doing for the last 24 hours, but most of that historical understanding is probably embedded in some kind of a model that I'm using to make decisions and choices. And then last, and perhaps most important, yes, we're in the cloud. Yes, we have capacity for data. Yes, we have capacity for compute. But we also have mixed workloads. We got transactions going on at the same time as analytics. And is it really that simple? We're in the cloud, so we can do it now? No, it's not. We need a system that can effectively leverage the capabilities that the cloud provides us to run mixed workloads, even if the ceiling is gone. So when I say we're moving from one era of the cloud, we are in fact doing just that, because with this sort of autonomous, intelligent, self-configuring, observability-enabled kind of a system, we can quote one of my favorite Paul Simon songs, "One man's ceiling is another man's floor." We can start wherever we want, and we can go as high as we need to go, because the system will gracefully do it for us. This is new. This is very new. As an industry analyst, I've been following workload management-enabled database systems for a very, very long time. They all work with ceilings, and they all work by swapping a little bit of work out of this workload for that other workload in order to try to do as graceful a job of degrading performance when something else enters the room as they can. This is different. It's a floor now. We can start wherever we want, and we can get to wherever we want on the basis of a system that knows how to do it for us automatically. It's very exciting, and I'm very happy to be here to talk to you about it. Joe, back to you.
Thank you. And
you want this?
No, we're good. I think you can hang on just for 1 minute.
All right.
We literally have our last slide, and we get one of our Q&A, so folks who have questions, feel free to gather around the microphone. But really just a quick summary of what we've covered. I know we walked through a lot of different concepts really quickly, but the whole idea is regardless of where you're at today or how you got to the cloud or you're just starting out in the cloud, this is actually a proven approach, and there are a lot of folks in the Google Cloud world that can help you there and make sure you learn from our experiences, learn from folks like Markus' experiences, and don't have to stumble through on your own. The other thing really is, and I'm not going to go through all of these details, but the key takeaway here is you don't have to worry about sharing data broadly just because somebody might run a workload that will wake you up in the morning. I joke about the 3 a.m. pager calls, but those aren't the worst because I get to do a lot of things at 3 a.m. I'm usually up anyway. The worst are the ones that happen at 10 o'clock on a Monday morning because that's when things are really, really busy and somebody decides to go run that trillion row table join. That's when you really don't want the pagers to go off. So with Data Boost, we believe we've made that possible, but I invite you to try and either prove it for yourself, or if it didn't work for you, let us know. We want to know what it is, and we will fix that. Thank you very much for hanging around and listening to us. If you have questions, we'll be hanging out right outside here. Thank you.